everyone. My name is Aubrey Doherty. I'm the Vice President of the Environmental Action Club. We're bringing this event to you today to hopefully shed light on the connection between the global disasters such as the hurricanes in Puerto Rico to the local disasters such as the fires up in Sonoma County. What I hope you take away from this event is maybe learn what you can do personally, locally, and nationally to help combat climate change. We as millennials have a special tool at our disposal, social media. And potentially what you can do today is learn something, take something away, and post about it using that media to maybe inspire others or educate others. Instead of posting about your pumpkin spice latte or whatever we post about, I do it too. It very well is the issue of our generation, and we should all care. We can all understand slivers of it, but everything is connected. So, nevertheless, I'll introduce my partner in crime throughout this process of the event, Laurel Havelsson. Sorry. Love you.
Thanks, Aubrey, for that awesome introduction. A round of applause. My name is Laurel Halverson, and I'm the officer of the Environmental Action Club here at College of Marin. I want to thank all of you for attending this event put on by the Environmental Action Club. Today we have a very special guest speaker, David Kunhardt, who is a member of several environmental organizations, but most importantly, he's a board member of the Environmental Forum of Marin, which also helped start Zero Waste Marin through one of their student advocacy projects. He has given very many climate awareness speeches to all ages, and is an active member of revitalizing and getting those around him aware of what needs to be done for this planet, as well as for ourselves. We do encourage questions throughout this talk, so if you do have a question, please feel free to ask. David's very knowledgeable, so he will be, of course, welcome to answer any of those questions. Now, please welcome David Kunhardt and his address on choosing to be bold and fearless on climate change.
Thank you very much, Aubrey and Laurel. On a specific note on questions, if I don't have an answer, I'm going to confess it. But here's what I would like to do with the questions. If you have a particular question about something that I just said, or something that's on a slide, do this. Point to the slide. Then I know you want that point to be illuminated, okay? Point. Got it? Point. Everybody point your finger, point there, point there. Okay. If you have a general question or general pushback, maybe you can save that until a little bit later. So, who the heck am I? After 20 years in real estate investment, I became aware of the climate crisis a little more than 10 years ago, and I said, you know, I've got to really change my life and start doing something about it. And so I left the big corporate environment working on real estate investments, and I went into the solar business. And I've been in the solar business ever since, co-founder of a small benefit corp that's a solar company here in San Rafael. But at the same time, I knew that solar isn't enough, and there's a lot more that we all need to do. And so, among other things, I have been trained by the Climate Reality Project. The Climate Reality Project has now trained about 12,000 people around the globe. I happened to do my training nice and fresh this last spring in Denver. I expected 350 or so students there. There were 970 students from 30 countries to hear from a variety of scientists and from the leader of the Climate Reality Project, Vice President Al Gore. It was, as was also said, I have an affiliation on the board of the Environmental Forum of Marin, which for 45 years has been doing environmental education here in this county, ending with teaching people how to do advocacy. So it's a very powerful class, and we now have folks in it who are range from about 19 to about 69 in the current class 44, 26 people. I'm also, full disclosure, very active in the Marin chapter of the Citizens Climate Lobby. The Citizens Climate Lobby you're going to hear more about in a little bit. That, I feel, is the biggest tool to address climate on the national level. Also going to talk about local solutions. I'm going to do a deep dive first into the bad news and then into the good news. So first in what the heck is climate change anyway? Well, and I'd actually like to, what do you think of when you think of climate change, and where do you get your information about climate change? Anybody? Anybody?
Al Gore.
Sure.
Where do you get your information about the climate? Most people say, well, the weather's pretty good here. I don't really have trouble. We're not changing. Well, we are in fact here. But we have a great blessing of being close to the ocean, which gives us very moderate temperatures and very little freezing in the winter and very little boiling in the summer, except for this October 1st. But climate change, I want to tell you, is very real. It is huge. It's systemic. It's complex. It's interactive. And there are positive feedback loops. Positive feedback loops is a little bit of a misnomer in my mind, but scientists use that because mathematically, if you add a factor and then it results in another factor and then it comes back and boosts the initial factor, that's a positive feedback loop. I'm going to show you some very specific ones. But this is where it gets pretty scary because we don't know how fast those positive feedback loops are moving. And they are moving a little faster than scientists had predicted just 10 years ago. Climate change presents existential risk and cost. What does that mean? Anybody? Existential risk and cost?
Outside of ourselves.
Outside of ourselves, that's one good meaning of existential risk. What else? Yes?
In some ways, literally a threat to our existence.
Perfect. Yes, did everybody hear that? Is it a threat to our existence? Would it be a bad thing if we were? That's a philosophical question that I'm not going to get into right now. But it also has very specific causes, and I'm going to dig deeply into that. And at the end, it is still addressable. It's something that we can take charge of. We can have a significant role, and there are a variety of things that give me hope, including that this club exists. When you said that your tool is social media, I was going to say your tool is youth and energy and hope. That's what I was going to say. Okay, to my surprise, the current administration released a congressionally mandated report called the National Climate Assessment Report. About 12 years ago, Congress said every 4 years we want to hear from the U.S. government, what do you think is happening? And they worked up their report, finished it in about December of last year. It was released. It was released not intentionally by the New York Times in a final draft form, and there were a lot of people who were worried that it wouldn't see the full light of day, but miraculously in the last 2 weeks it has seen the light of day. I was concerned that it wouldn't see the light of day because on the very day which was supposed to be the deadline for a federal scientific agency to receive it and translate those findings into actions, the present administration eliminated that panel on the Friday afternoon in August, just without saying anything to anybody, just eliminated it. So I thought, okay, that report is done. Look that link up, and I'm going to come back to this, but a lot of what I speak from is going to come out of that report. 470 pages. The executive summary has all sorts of conclusions. Every single paragraph that has conclusions has within it a statement of what the degree of likelihood and certainty that the scientific community has about those conclusions. And so we're going to get to them. So what are the observable symptoms of global climate change? What can we poke at? What can we see and know? You have a question, but you're not pointing. Yes? Very good. And I'm gonna summarize 9 of those. First, there's just plain warming, and you have a point.
Yeah, what about hurricanes?
Yes, we're going to get to that.
Okay.
That's one of the 9 for sure. But first, there's just plain global warming, and that's measurable. And if you look at the hottest years that humans have ever measured since the 1880s, when we have kept global average temperature records and measures, guess what? 15 of the 16 hottest years ever recorded have been since 2001. Only 1998 is the only prior one. And the hottest year is the most recent year. This October 1st San Francisco experienced its hottest day ever in recorded history. 106 degrees in San Francisco. And that was part of the symptom that we're going to get to on wildfires. There is a projection that's been done. Now, this is a moving projection from 86 to 2099 that shows in a cyclical fashion of how many days per year are hotter than 95 degrees. And notice that this is the best guess projection of where temperatures are going. How many of you can work outside when it's hotter than 100 degrees? I can't really. Look at all those areas that may have to be effectively abandoned. Climate refugees is already a phenomenon. What's another symptom? Symptom number 2 is storms and floods. This is Hurricane Harvey. 51 inches of rain in 3 days, more than 7 people dead, several tens of thousands of people displaced, and billions of dollars in cost. I'm going to talk a little bit about the causes of that, but it really truly was, as our president said, an historic storm. Look at the, can you imagine your house being underwater right up to the rafters? That's one of the many, many images of houses. But what made Hurricane Harvey historic? How did it get to be as extreme as it was? Never before has 51 inches of rain landed on one American city in 3 days. Well, first thing is that the Gulf of Mexico is about a foot higher today than it was just 30 years ago because of the warming of the ocean and because of the beginning of melting of land-based ice. Second, and so when wind comes towards the shore and the ocean is a foot higher, it just makes it that much more likely that things will flood. Second, warmer water everywhere, and this is a key fact for all of this talk. Warmer water means more moisture in the air, more rain. That leads to the 51 inches. Warmer oceans also means stronger winds. And a final thing is, this is less of a certain conclusion, that the jet stream has done some what's called lagging or stalling in place. This is an image just after Hurricane Harvey, and the talk really does get better. I want to tell you, when Hurricane Harvey came in, this is the remnants of it here. It came in and it hit the jet stream, which was looped all the way down to here, and it did a circle, so it then bounced off up that way. That circle allowed the same rain deposits to repeat in the same place. The jet stream normally is vibrating, in past decades, sort of in northern United States, southern Canada, but the warming of the Arctic has caused the jet stream to deflect and move down further into these big loops down in. And then you can also see the series of storms that also originated over hot water, 95-degree water. And this is Irma, the big one in the middle, Tropical Storm Jose, and just off the map to the right is Maria that came and hit Puerto Rico. And that's one of the many images of devastation in Puerto Rico and other floods. But floods are not unique. They have been increasing in a variety of places around the globe. This is just a year and a month or two ago in Louisiana. 13 died, 60,000 people homeless, some of the similar conditions. And just at the beginning of this year, has anybody heard of the phrase atmospheric river? And, well, this is a satellite view of an atmospheric river that starts with Hawaii and races over towards the middle of California, loaded with water. And the very next day in San Jose, no surprise. Well, they were surprised. They were totally unprepared for the volume of water that hit. But this has happened in many states in the United States and also in many parts of the world. This is this year, September. In India, Nepal, and Bangladesh have had some of the worst storms and floods in years, which are exacerbated actually by melting ice off of the Himalayas coming down through Bangladesh. So, the new normal with global warming and it's completely associated with global warming. The new normal is excess moisture in the atmosphere. It's believed that we're going to have hundreds of times more in the way of storms and rain in the coming century than we did in the prior century. Moisture is itself a greenhouse gas, so it adds to the effect that I'm going to talk about, the cause that I'm going to talk about in a little bit. So that's one of the positive feedback loops. Well, the X is a symptom number 3. The exact same warming that causes more moisture in the air also causes land to dry out and causes drought. The exact same heat does 2 opposite things depending upon patterns that are prevalent. This is the hardest slide for me to talk about. In India, just a year ago in May, there was an epidemic of suicides as a result of the degree of drought and lack of ability for farmers who have been farming for thousands of years in the same Delta region to bring anything to life. In the United States, this is close to where Laurel's family comes from. This is Colorado. As warming has affected all of us, it has gone up in elevation. It has reached up in elevation. As warming reaches up in elevation, a particular bug, called a pine bark beetle, doesn't have just one cycle, which dies off in the winter. It has 2 cycles in a year. And so millions of trees have been dying in Colorado, in the Rockies, and in the Sierra. This is in the Sierra. It's estimated last May, a year ago May, 29 million trees in California as of May. What's the product of that? What's the next symptom? This Sunday, I had the privilege of listening to Dr. David Tackerley from Berkeley, who also taught at Stanford, and he is a specialist in the topic of forests and forest restoration and land conservation and so forth. And he said, well, there's no one cause of wildfires, there's 3. One is fuel, particularly where you have dead fuel. And ironically, particularly if you've got after a winter, prior winter was so lush with moisture, there was a whole lot more growth and a whole lot more fuel available in Northern California. And particularly if there are diseases of those trees, then they're more susceptible. The second condition is the rest of the conditions: heat, lack of moisture, dryness, dry ground, drier than normal. And California has been drier than normal. And you add to that wind, and then you have the third factor, ignition. And that could be human, it could be a cigarette, it could be a lightning strike, it could be a falling power line, it could be anything that causes that ignition if you've got the rest of those conditions. There have been an unprecedented number of wildfires in the United States this year, including the one that hit so badly here in Sonoma, Napa, and Solano counties. Hotter and drier air, dead trees, dry fuel, hotter fires. And the fire experts will tell you these fires are getting hotter themselves. They're burning some of the ingredients of trees which normally thrive from a light fire. Bristlecone pine is one that roots pine. It bursts open and can seed the ground after a fire if it's not a super intense fire. But the current fires are super intense. The fire season is also a lot longer because snow is melting earlier, so it starts earlier, it's gone later, this year right up into October. And we're not alone on this front either. There's Australia's wildfires this fall. So there's another whole topic, symptom number 5, which is the spread of tropical diseases that didn't used to go beyond the tropics, but now because of warming air, have gone beyond the tropics. Look at all of those different things, starting with West Nile virus and ending with the Zika virus. Beyond those sophisticated tropical diseases that live better in the heat, people don't live so much better in the superheat. On days when it's over 120 degrees, as it was several days in Pakistan, This is a full 2 years ago in Pakistan, 1,200 people dying just because of the heat, from heat frustration. Last year, 3,200 people in India. So the heat alone can be deadly. There's another thing that happens when you pollute the air and fill it up with greenhouse gases. This is New Delhi. Right now, this week, United Airlines is not allowing planes to land in New Delhi because the air is so polluted. It's the equivalent of smoking 3 packs of cigarettes when you get out of the plane. It is estimated that there are over 2 million people a year who die prematurely as a result of air pollution in India alone. In China, which is experiencing some of the worst, they're taking a very strong look at what are the costs of air pollution and what are the costs of not taking action. And air pollution has cut life expectancy in China. There are a number of places in the United States that have much worse air pollution than we do right here. We're very lucky right here where we are. So symptom number 6, Arctic ice disappearing. Look at this one real closely. The top image is from, what does that say, 1984. And the bottom image is from 2016. The brighter the white, the deeper the ice. Deep ice has been melting and shifting, and every year in the summertime, it revolves around and moves out past Greenland. And this is from the same month in each of those respective years. Positive feedback loop. What happens when there's plenty of snow and ice on the top of the planet? What happens?
Reflects heat.
Reflects heat because it reflects the snow, the snow and ice reflect the light and the heat back into outer space. When that snow is not there and you have that huge gap that's over Alaska here in the lower image, where does the sunlight go? Where does the heat go? It goes into the ocean. There's an unprecedented number, and this is, maybe you think of this as a good thing, plankton and various algae growing in the Arctic now. And that is a source of oxygen for us, so that's cool. But it's a dramatic difference, and it's getting worse. If you have floating ice and it melts, does that change sea level rise? Trick question. No, it doesn't. Yes, Sophia says correctly, no, it doesn't change the sea level rise at all. But if you have land-based ice and it melts or it falls into the ocean, yes, it does. And the second biggest land-based ice is Greenland. And here's an image from 2004 to 2014. This is just a decade. And that graph shows the depth and mass of ice that has left Greenland and gone into the ocean. This spring, there was something unprecedented. There were peat fires in western Greenland. Peat moss in the ground drying out enough, first of all being revealed enough, and then drying out enough so that it caught fire, spreading ash over the ice and snow, making the ice and snow darker, melting more ice and snow. What's the result of Greenland melting? Sea level rise. Days like this in Florida. There's an increasing number of days like this when there's no hurricane and no storm. This is water surging up backwards through the storm drains in southern Florida and flooding out the streets. They're spending hundreds of millions of dollars raising streets, changing the drainage system, adding check valves, one-way valves for stormwater in the urban areas in southern Florida right now. If you talk to the Republican mayor of Miami, he's going to say this. You got that? Does anybody not be able to read that? You want me to read it for you?
Yes.
You got it. That means yes, you got it. You don't need me to read it for you.
Yeah.
This has become a bipartisan issue, and somebody remind me to talk about the Climate Solutions Caucus, which had its origin in Florida. Siberia. This is the next symptom. This is more than a kilometer across. They nickname this the gateway to hell. This is the result of melting permafrost, symptom number 8. Warming atmosphere in all sorts of parts of the Arctic Circle are causing permafrost to melt and collapse and reveal and release methane. Methane. You know what methane is, right? That's what is put into our natural gas in order to make it stick. It is also much more powerful than CO2 as a greenhouse gas. It's estimated over 25 times as powerful as CO2 as a greenhouse gas. So again, the more warming, the more melting, the more methane, the more greenhouse gas, the more warming. Yes?
So can you explain how this womb in the earth was created?
It just started to melt and it started to collapse. If you look very carefully, there's kind of a sandwich in the upper rim. There's kind of a sandwich which has a whole lot of white in it. That's some of the permafrost that is still frozen. And it's when permafrost melts that it allows the surface to collapse and all the trees and everything else just to collapse into the ground. This is one of the things that we don't see because we're not as affected by the amount of warming that's occurred. This is an image, and it's actually a still from a moving image, which if you go to that site, you can find, it's the site managed by NASA, you can find a moving image of the change in temperature. The Arctic Circle is changing much more than the rest of the globe. On average, the globe has gone up by 1.5 degrees centigrade. We're pushing up closer to 2. In the Arctic Circle, it's up by 8 degrees. Last Christmas, the North Pole was 50 degrees Fahrenheit warmer than it typically is. 50 degrees warmer. It's about 36 degrees above freezing on Christmas Day in the North Pole, no sunlight. When that happens, there's more permafrost that melts. Here's an example of the product of permafrost melting in Alaska. And there are a number of communities in Alaska that are falling into the sea or falling into the ground, just like this. This is kind of being kept quiet right now. The folks in the USGS who are studying this have been reassigned to accounting positions right now. Now, with all that extra heat, symptom number 9, most of the heat, actually, which holds heat better, air or water?
Water.
You guys are smart. Most of the extra heat is going into the ocean, being absorbed by the ocean. That National Climate Assessment report that I've been quoting says the world's oceans have absorbed about 93% of the excess heat caused by greenhouse gas warming since the mid-20th century, making them warmer and altering global and regional climate feedbacks. Very high degree of confidence in that conclusion. What's one of the results of that? Anybody heard of the Great Barrier Reef destruction? About just under 30% of the Great Barrier Reef has died. Almost 50% of the total ocean coral is dead right now after 3 years of bleaching. Anybody seen the wonderful, stunning, beautiful film, Chasing Coral? Anybody seen that? I urge you to have a session. Get the film. You can get it through Netflix. It's devastating. It's beautiful. It's revealing. There's some really good guys who do a lot of swimming in it. And it is absolutely moving. And in the times that I have seen it with a couple of different groups, a number of people end up in tears. And it makes you want to run out and start doing something right away. But there's a link to that film. Okay, so we have a lot of characteristics of climate change. It's real, it's huge, it's systemic. There are positive feedback loops. There is existential risk and many costs. Think of all the insurance costs of those storms, and those droughts, and those fires. And there's coral die-off in the Arctic. It's changing, and the ocean is changing. So, what the heck is causing it? First of all, this was actually one of the stunning things that. Get directly to the answer. And this is in the National Climate Assessment Report again, with a 95 to 100% certainty that human influence has been the dominant cause of the observed warming in the 20th century and since the mid-20th century. There are no convincing alternative explanations. You may hear somebody say, oh, well, it's sunspots. Oh, well, it's volcanoes. Volcanic action actually does increase the amount of carbon dioxide usually, and it can increase the amount of particulate matter, which can have a cooling effect, not a warming effect. Humans are, it is believed, about 60 times more responsible than any volcanic activity. Again, that's the source. Go to that source. Don't believe me, go to the source. But this is something that really surprised me when I took the training. How thick is the Earth's atmosphere? Anybody give me an answer? How thick is it?
Less than a mile.
That's not true. Keep going. Think of it. People can just barely breathe on the top of Everest, which is 29,000 feet, right? So that's 5 miles. So how thick is the atmosphere?
20,000.
It's thicker than 20,000. Let's have some more guesses. If you got into a car and started driving straight up, and this is so ironic because you're outside on a sunny day and you look up and it just looks infinite, right? That blue sky just looks infinite. If you go outside and get in a car and say, well, I'm going to drive straight up, you would drive from here to Sausalito and you would be out of all of the air. Here in Sausalito, it's 10 miles, a little more than 50,000 feet. That's all. And as Carl Sagan, wonderful poetic scientist, late scientist, said, it's about the thickness of a shellac on a classroom globe. And yet, what have we been doing to that for 150 years? We've been treating it as an open sewer. Okay, what's the effect of that? There's one group, which is the Naturegeosciences, who has put this back to 66 million years. I don't know how they get that, but others say at least 3 million years. The amount of CO2 is higher today than any time in the last 3 million years. So let's dive into that a little bit more closely. This is an image of a graphing of results of investigating drill coring of the Arctic ice and looking at the content of the Arctic ice, content of carbon dioxide, and you see that there's kind of a sine curve over time. And those are broadly associated with warmings and coolings of the planet, and sea level rise and sea level fall. And the last time it was super low was about 20,000 years ago with Ice Age, right? You look at what it's been done. But in all of that time, and there are others who have a graph that does go back 800,000 years, and in all of that time, it hasn't gone over 300 parts per million. Where are we now? We're actually over 410 parts per million of CO2 alone. It's actually a small fraction. I mean, it sounds like a small fraction, but it has a huge effect. And if you add to that the methane that's being released, it's thought that the equivalence is roughly 490 parts per million. But the most shocking thing is look at how vertical the line is, how much we have changed the content of the atmosphere, how quickly we have changed the content of the atmosphere in the last 150 years. Here's drilling in a little bit more closely to it and associating, this is the time in which we have been burning coal and oil and natural gas. Note also that the downtimes are times of depression, the downturn in the 1930s, the downturn in the beginning of the 80s. The nick up there at the top is the downturn that we had globally in the economy in 2008-9. But notice it's also leveling off. Let's look at it, or look at a similar curve of the temperature. And this is what, to me, brings these two things together. Is you see that curve going from 1850s to 2016, and then you look at this curve of temperature. They've arbitrarily set the year of my birth as the 0 line, and so that's why there's some negative numbers before that, and it's gone up still more. Remember what I said, that 2016, the hottest year ever. And there are more and more extreme heat days in different parts of the globe. How is that caused? Well, since the 1880s, scientists have understood the greenhouse effect, which is that if you load up the upper atmosphere with greenhouse gases of any kind, and I'll show you the types in just a second, light can come down through and it can't escape. It can't release. And so heat gets trapped, and so that thin band gets warmer and warmer. These are the principal greenhouse gases: water vapor, nitrous oxide, a product of burning coal and other things, methane, and carbon dioxide. Carbon dioxide is the biggest, and it is also perniciously the longest lasting. The half-life of carbon dioxide in the atmosphere is 100 years. Methane tends to be much more precipitate and only stays a dozen years or so in the atmosphere. So methane's the hot, short risk and problem, which is being accelerated, is accelerating the cycles. Carbon dioxide is the underlying problem. How does it get into the atmosphere? What are the things that does it? Well, these are many of the human activities that does it, from industrial processes to industrial agriculture to, if you look on the upper left, thawing of permafrost, over on the right, forest burning. And yes, forest fires are another negative, or I call it negative feedback, another positive feedback loop. Transport, you name it. A lot of the things that have made us wealthy are the things that are causing those gases. So that's an issue for us, right? What can we do? It is addressable. Now, I want to ask you guys, do we need to do anything about this? We definitely do. There's a speech, and the club made several copies of it, which are over there on the back, by James Hansen. Dr. James Hansen used to work at NASA. He was the chief climate scientist at NASA through the 80s and 90s. And he was the first one to appear in Congress in the 80s to say, guys, we have an issue. This has been known by the scientific community since the 50s that it's operating against us, but it's now starting to get real. And they asked him, well, what would be a tipping point? What would be a point beyond which we should not go? And he said, well, 350 parts per million. How many are we today? 410. He got so upset about this topic that he left government and has been an advocate on the outside ever since. And yet he's there in Bonn. Does anybody know what COP23 is? The Council of Parties. This is the UN process. So the UN has been studying this issue for 40 years, right? And the 23rd Conference of Parties, COP23, is occurring in Bonn, Germany, right now. And there are a number of experts there, and James Hansen has his beautiful speech. I would urge you to read the whole speech. But his call to action is the science is clear. CO2 is the principal knob that controls global temperature. It already drives increasing climate extremes, cyclones, typhoons, hurricanes, and there is worse to come unless we act with resolve and without further delay. Well, we do have some solutions that we're operating on. And this was the 2015 COP21. This was the time when the globe came together. And I'm going to just come out and say they came together largely because the two biggest polluters in the world, China and the United States, leaders got together and said, hey, nobody else is going to do anything unless we do something. And so 6 months before this meeting in the fall in Paris, they agreed, Premier Xi and President Obama agreed that they needed to do something, and they needed to put a signal out to the rest of the countries in the world that they were going to do something. And once they did, well, developing nations who were for 20 years saying, okay, it's fine for you developed nations with all the wealth to tell us that we can't start burning gasoline and oil and so forth. It's fine for you to tell us that. You want to keep us poor. And other developed nations were saying, well, you're the worst, so you got to act first. And so it was that tipping point in the political sphere that allowed all the nations to come together. And unprecedented, all but 3 nations in the world came forward and agreed and signed on. I apologize, all but 2, Syria, which was in the depths of civil war, and Nicaragua. Nicaragua, why? They said, this isn't good enough. We want it to be an even better agreement. Well, 2 months ago, Nicaragua said, okay, it's not perfect, but we're in. 2 weeks ago, Syria said, yeah, we're still having problems and there's not a whole lot that we can do, but we're in. because we understand the science. So there's really only one country in the world at this point that is at risk of not being in on this global agreement to take action. But we're not out yet. We're still actually legally and technically in. And what are we actually doing? In 2016, this is a kind of an overall look at where our power comes from. And the power sector is not the only sector that's generating greenhouse gases. Transportation is a huge one, but the power sector is a very big one for sure. Well, in 2016, it used to be that coal represented more than 40% of our electrical generation capacity in the United States. It's down to 30, plus or minus 30%. Natural gas is responsible for offsetting a lot of that because it's now up at a third, whereas it was only about 20%. Nuclear is at about 20%. That's actually decreased since California has closed one of its 2 nuclear power plants. But there's another nuclear plant that opened up in the east. So it resides at about 18-20%. Petroleum is a very small amount, typically in island states, Hawaii and Puerto Rico and a couple of the other island parts of the United States still burn petroleum to generate energy. But the renewables here, it's hydro, wind, biomass, solar, and geothermal. It's all of those. Solar and wind, which everybody hears about all the time, it's only about 9-10% in that year of the aggregate generation. So we got a long way to go. But it's changing, and it's changing quite favorably. First half of this year, bless you, renewables represented 20%, over 20% of U.S. generation for the first half of this year. Very good news. And there's some really big projects that are being done. There's also some extraordinary inventions that are underway. Wind turbines. Maybe several of you have seen, you go over the Altamont Pass and you see these turbines that are up there. They're sort of like mixed masters and they're pretty dangerous and some of them are not working. These guys, bigger than a 747, turn much more slowly. They're almost no risk to birds and other flying creatures. And there's just an extraordinary development in how well those things function and how much energy they put out. So, again, this is not the body of how much generation we have in all. This is the new generation capacity last year. For the first time, wind and solar overtook natural gas as the new kings of generation of energy of all kinds. And nuclear, there was one plant that opened up last year. And so wind, for example, is really big in some of the red states from Iowa down to Texas. And we have about 75 gigawatts, 75 billion watts of wind power installed enough to power 20 million homes. So we are making a change. Now, this is a little hard to read, but the fundamental message here is that every year, predictions in the last 20 years, every year that a prediction is made about how much generation is going to be new stuff, each year we have fallen short. So on the left, the wind, those colors on the top is, on the bottom is the oldest projection, and on the top is the newest projection from Bloomberg New Energy Finance. So every year those old projections have said, oh, we're only going to do this much. And then in fact we've done that much. Same with the solar business. So we are surprising ourselves with success with renewable energy and the volume of it. In solar, which I'm in, this is sort of end of 2016, 260,000 jobs. How many jobs are there in coal extraction in the United States? Say again?
Just 5.
No. There's fewer than 70,000 jobs in the United States involved with coal extraction. That includes mountaintop removal and digging under. Coal is by far the most dangerous method of getting fuel for energy, by far the most dangerous, far more dangerous than nuclear. There have been dozens of people in the United States alone, let alone India, China, and other places, that have died in the last 30 years from coal extraction. How many people in the United States have died from nuclear in the last 40 years? 0. Anyway, that's a little bit of a distraction. Solar is really big, but 260,000 solar jobs that can't be exported compared to less than 70,000 in the coal sector. Whose jobs are we protecting when we take political action? My sister lives in Chile, And so I love this slide. Look, in end of 2013, they had 11 megawatts. That's about as much as we have in the city of Richmond, California, of solar. In the end of 2014, 420, so it went up by a factor of 40. In the end of 2016, it was up to 848 megawatts. And then in 2016 and on, this is how much solar is in the works in Chile, which has particularly nice conditions for solar because it is, it is close to the equator, so the sun is relatively directly overhead. A lot of the altitude is high, that's 13.25 gigawatts. That's as much as we developed in the United States in the whole year. Its elevation is relatively high, so it's cool. The perfect environment for solar is sun overhead, cool air, because the productivity falls off when it gets super warm. So it's a very good market. Now, let's get back into another aspect of good news. This is looking even more closely at that curve of greenhouse gases that are being generated by all of us in the world. Look at how it's flattened out. Again, look at how there's a dip in the 2008-2009 area, when the dip was caused because we weren't doing as much. We were not as successful economically. But the economy of the world, and particularly the United States, and particularly of California, have been going like that, and yet the carbon dioxide has leveled off. Very good sign. And even better sign, this is an Indian professor or researcher at Brookings Institution who did a great paper that showed that the growth of GDP, gross domestic product, in the global countries has now separated from the growth of greenhouse gas generation and fossil fuel burning. For the years and years, ExxonMobil and the rest could say, well, you need us in order for your economy to grow. No, you don't. No, you don't. But we still have a lot to do. If we do nothing, if it's business as usual, the temperature rise is going to go blasting up to 2 degrees centigrade. What's 2 degrees centigrade in Fahrenheit? Multiply by 9, divide by 5.
2 times 9 is 18.
If
Divided by
your
5.
temperature went up, whoa, it's getting too warm in here. If your personal temperature went up by 2 degrees centigrade, it's going up by 3.6 degrees Fahrenheit, and you got 102.2 temperature. Is 2 degrees a good thing? 2 degrees centigrade a good thing? Is that something that we can stomach? Anyway, we are working to make the curve that light blue curve, and we're showing some real success. What we really need to be doing is the green curve. We really need to be pulling carbon out of the atmosphere, really stepping away from fossil fuels, and I'll get to some of the things that we can do. This is an all hands on deck situation. We absolutely need to get out there and start work. We need to change our energy sources. We need to eliminate waste and hogs of energy. We need to rediscover natural solutions. I'll talk about that in a second. And we have to, in certain ways, alter the material world. We have to ask questions at every turn about, if somebody gives you a solution, say, oh, well, we're fine, we've got these new fracking wells, and that's going to take care of the ask questions, ask questions, ask questions. We need big policy changes. And we need 100,000 solutions, locally, statewide, regionally, nationally, internationally. We need you. Locally, what have we got? We don't have industry in Marin, right? We don't have big smokestacks. We don't have big power plants. We don't have big emitters, single emitters, point source emitters of greenhouse gases. We do have some methane generation in our farms, and there are some farmers who are really working on that and are using that as a carbon neutral fuel source. But transportation is more than half. Buildings are another 35%. Agriculture is the next one. So transportation is the thing we really need to hit locally. But my favorite in this group is the ugly color in the upper left. It's the Chevy Bolt. The Bolt has a 236-mile range, and it's super quick and it's super smart. So this is one of the things, range anxiety is one of the things that keeps people out of electric vehicles. That plus the new Tesla, if it'll ever come off the line, are overcoming that anxiety in a somewhat reasonable price point. We're helped by a subsidy that's coming from the federal government, which the House of Representatives today voted to eliminate. It's not going to go through. We're not going to have tax reform. That's another topic. But electric bikes is another really cool way to go. A lot less expensive than a car. And there's some really cool electric bikes that are out there that have great pickup and great style and great coolness, from classic commuter bikes to really quite racy. The one on the lower left is a Pi-cycle. That's a Marin-based invention and company. So there's a lot of stuff that you can have or work on that will take all of the greenhouse gases out of the atmosphere from your ride to and from and around. What are some of the natural solutions that we have? Well, all of these are kind of natural solutions. And at this point, I want to highlight, if anybody has not heard about this book, Sausalito resident is the Project Drawdown, and this book edited by Paul Hawken, Smith and Hawken, several other sustainable businesses, lists the 80 solutions that are being used around the world. There's the smiling guy, that are now being used around the world to avoid greenhouse gases and to regenerate health of our planet, plus 20 more that are in the invention stage. So you've got 100 different solutions that he lists, and some of them are listed here. Reforestation. Silvopasture is both trees and grazing in the same location instead of wiping out all the trees in order to graze. Carbon farming. Ask Joe Mueller about carbon farming. It is a wonderful new thing that Marin is advancing. Just spread a little compost and you will greatly enhance the amount of growth of the root systems of grasslands, and you will retain more water, fix carbon for at least 30 years, and make for a healthier plant and for healthier animals that are grazing on those. Wetlands restoration, kelp farming. If you wanted to do a really cool business that takes no fertilizer, no fossil fuel products whatsoever, invent a vertical farm that floats in the ocean and start selling the products from that vertical farm. You've got all the nutrients you need right there in the ocean, quite naturally. Less food waste, that is a huge thing. So what can you do individually? I want you guys to talk about these little things, if you will. Drive an EV, electric vehicle, drive an e-bike, or just a regular bike. Put solar on it, use less energy. Here in Marin, we have a really cool institution called Strategic Energy Strategic Energy Innovations. And this gentleman works there now for just a couple of weeks. And Strategic Energy Innovations will frequently tell their clients, many schools and so forth, what is the least expensive and most environmentally correct kilowatt that you can have. It's the one that you don't use, right? Stop using energy, turn the lights off, and now put a price on carbon. There are a number of people, and this is in my notes, there's a couple of dozen people that are well known around the world, including Elon Musk as for example, who have said, okay, if you want to do the most powerful thing, and including Paul Hawken, if you want to do the most powerful policy solution, is put a price on carbon, tax the polluter. It's the same thing we've been doing with cigarettes for a number of years, and it will drive down the demand for that product because the cost goes up. And by comparison, better solutions will be less expensive, and the economy will take over, and a million solutions, a million decisions in the economy will get us to a yes. Here's a model of how that solution works that Citizens Climate Lobby version of that solution starts on the lower left. You tax the companies that are pulling fuel out of the ground one way or another. This is coal, oil, and then or imported at the port. That money goes to the Treasury, and the Treasury turns around and writes checks to every household on an equal basis. So it's a carbon dividend plan. And then what does every household do? Well, for the short run, while they're still working with that old gas-driven car, they're going to spend a little more for the carbon-intensive products. But they are more and more going to switch away from carbon-intensive products to other products, and they are going to grow the amount of fossil-free products in the world. This solution, the econometric modelists that picked this up and said, wow, we can create over 2.8 million jobs. We can, if you dividend the money back out, as George Schultz, conservative George Schultz says, if you dividend the money all back out, it's not a tax. It's putting the pain where it belongs. You're internalizing the external costs of fossil fuels into them, and then you are setting the rest of us free to make better decisions. So, let's see. Here are some of the people. There's actually a bipartisan group. Citizens Climate Lobby is bipartisan. There's a Republican group, which is George Schultz, James Baker, Henry Paulson, former Secretary of the Treasury under Bush. Greg Mankiw was former chair of the Council of Economic Advisors under George Bush, and he's chair of the Harvard Economics Department. All of them say, put a tax on carbon. It's the most important national solution that we could do. And as well, Rex Tillerson is on record saying repeatedly and describing in great detail the positive effect of taxing carbon. There are, since this spring, a number of major international oil companies who are saying, tax carbon. Right now, with all the different decisions by all the different countries around the world on carbon, all the different pricing ideas, big companies don't know what to expect. They don't know what to plan for. They don't know where to go. But if we set a tax and say, this is going to go right into the future, particularly if it rides steadily upward into the future, those companies understand how they will respond, and they will start providing more clean fuels. But can you read some of those other names? There's some great people who are behind this. Anyway, here's some ideas. Anybody here wants to start a business? Anybody here is motivated by the heavy motivation of College of Marin to have you think about starting new businesses? Here are some that you can do. And I love the first one. Actually, one of the current members of the Environmental Forum Marin Masterclass, who lives in the Canal District right near a car repair place, said, well, instead of throwing away our old cars, let's convert them to electric cars. I've already talked about the vertical ocean farm. Why do people fly around so much? Because they don't really trust electronic communication. They want in-person communications, right? If one of you can design the best ever three-dimensional instant operating Skype device, you can relieve us of a whole lot of airplane flights, because you can have conference rooms that have real three-dimensional images and real communication, and you can see body language, and you can see how somebody's going, and when you say your idea. Pull carbon out of the atmosphere. There is a company called Global Thermostat that is pulling carbon out of the air and making carbon fiber products. There's another one that's pulling carbon out of the air and pumping it into greenhouses in Canada and growing tomatoes in the wintertime. That's not a carbon negative, but that is a carbon neutral phenomenon. There's another company that is taking carbon dioxide out of the flue stacks and, for example, cement plants, and immediately creating with that a kind of limestone pellet. And they're selling those limestone pellets to the same people that are buying the concrete aggregate product, and they're embedding the carbon into concrete so that it will stay there for 200 years. So there's some hopeful, cool things that are going on, and all of them, by the way, all of these businesses would be more successful if we had a price on carbon. So, I am going to say thank you very much. This is fun. I'd love to take more questions. Yes, sir.
There's one thing that you didn't mention, which is ocean acidification.
You know, I should have, and you're absolutely correct. And the death of coral is thought to be a combination of heat and acidification. And acidification is occurring, and it's a big threat to a variety of other crustaceans, right? This year,
Too.
say again?
Mollusks as well.
And mollusks, yes. Other questions? Yes, sir.
So you mentioned electric vehicles and the benefits, but I was wondering if there is a downside in the production of the batteries and the parts and everything like Tesla, for example.
All electric vehicles are pretty much using the same battery technology, which is kind of the highest energy, which is lithium-ion. Lithium is not usually plentifully available, and its mining does cause some issues. And there are other chemicals that are, you're most welcome. There are other chemicals that are, let's say, not readily disposable. And so people, you need to find the answer for the recycling of those batteries. And a lot of the ingredients can just be recycled right back into a new battery. The problem with aging batteries is that the anode and cathode tend to get crusty, and they tend to have dendrites that form, which will cause kind of a short circuiting and just a wearing down of the power of the battery. But there are new flow batteries that are taking care of that. There's a vanadium flow battery that's being produced by a company in Oakland called Avalon Battery. It's a Canadian and American company, but they're in Oakland. Avalon Battery is growing fast. They're working together with Flextronics and a tilting solar array company, and so that they can store all this energy during the day and then let it out in the evening when we need energy the most right now. And so there are ways to tweak and ways to improve, but you're absolutely right to put your finger on, are there toxic aspects of these new technologies? Always. I said ask 100 questions when somebody comes forward with an answer. Laurel?
Also to add to that, to answer your question, the impacts of making those batteries are not as substantial as the impacts of CO2, methane, and all those other horrible gases.
Yeah, I gave a talk and said, wind power is now the cheapest generator of energy in the United States, cheaper than coal. And somebody said, but what about the birds? Well, the number of birds that are estimated to be killed by coal each year in the United States is something like 7 million. There may be 20,000 birds that are killed by particularly the old style wind that goes faster and not the big new ones that move like this so elegantly. And so look at the opportunity costs. The biggest causes of risk to birds are coal, glass windows, and cats. I'm not kidding you. I'm not kidding. What other questions you guys have? Come on. Yes.
So when you talk about all the jobs that solar is creating, are those jobs long-term, or are they are they temporary as in them installing new solar?
That's an excellent question, and it's a mix, because it includes, and there was another slide I showed that said all of renewable energy is thought to have created already about 2.6 million jobs in the United States. A lot of those are in kind of what I do, which is develop, figure out, plan, do the legal documents, finance, make it happen. You're right, construction jobs in any sector are short-term, but the more people that are trained and the better they are trained, the more opportunities they have, and the lower the cost of the installs, and the more, California's got huge amounts of, and we're biggest in the country with our installs of solar. Still only about 7% of households have solar. There's a huge market. So don't worry about the expiration of those jobs quite yet. There was another question. Yes?
I read that the quality of the jobs aren't that great, that the pay is low, there's not benefits to solar, a lot of the solar jobs that are in California.
I think that a lot of information that's been put out there by the international, what is it, IBEW, what is that? It's the electrical workers, that says you've got to have union jobs and not these scummy, off-union companies. As a matter of fact, my company does mostly municipal, so we do mostly union workers in our own business, but they are good paying, they're better paying than flipping burgers. It is true in the United States that a lot of the growth of jobs has been on the low end. It's been in the service sector, it's been in the minimum wage area, not in the upper ranges, and we've become a lot more efficient at some of those upper range skills, computer software and other things. But there's a variety, there's still a variety, and the better we get at installs, the more time can be focused on those sort of high value jobs. Now, who had their hand up first? Aubrey. Oh.
And just to address that as well, these new jobs also in terms of installing solar or green electricity, the market for them is growing. Therefore, salaries are growing. There's higher salaries in spheres where there's more money, where there should not be. So the coal organizations are big, so they pay well. So does BP. And as solar is growing, they'll pay better and better.
Yeah, on the same day that Scott Pruitt said that he was going to cancel the Clean Power Plan, 3 coal companies announced closures of coal plants in the U.S. The market has moved way past coal, way past. They are on the way out, for sure. Now, Aubrey.
Yes, and also to add to that, if you think about the health risks from working in coal or, gassing or any of those, you're not going to see as many health risks when you're doing solar or clean energy. And furthermore, there's programs that are trying to transition coal miners and et cetera into the clean energy so people do not lose jobs and there's a consistent income.
Yes, sir.
One of those programs is drilling graphite mining instead of coal mining because it's actually safer. And graphite's used in a lot of electric ion batteries. And they're able to use their same skills of landscape mining and they still do what they do.
Yeah, in fact, you reminded me that I didn't even complete my thought on when I was mentioning Avalon battery. They use vanadium, which is a byproduct of coke and coal and petcoke and so forth. So it's a pollutant that can be incorporated into and create a 20-year battery. That's a flow battery that doesn't have that short life problem that lithium ion does. Any other questions? I don't want to capture you beyond, but I can stay and answer questions one-on-one if you don't have any more group questions. It's up to you. Thank you very, very much for this. Oh, there is a handout somewhere back there of all the actions that you can take.
We still need
It looks like this.
Still second.
Oh, okay.
David, thank you so much. So, hello again, everyone. Thank you so much for attending. Thank you, David, for such an excellent presentation. We, the Environmental Action Club, it is our duty and has been our duty to bring such wonderful people and events and opportunities to you, and we hope that it inspires you, and I'm sure it has, to take action, to become a part of the environmental community. And you can start, through social media or by picking up one of these slips at the door, picking up the outline, or also taking classes, joining the Environmental Forum, joining Sustainable Marin, and joining any organization that captures your attention because they are welcoming and we need more people on the forefront thinking of these ideas, how to improve our world in terms of environmental sustainability. So,
we need you.
we need you, yeah, absolutely. So, and you can also start with taking classes at the College of Marin. Actually, we use, at the this semester, there's the climate change class that uses Drawdown as the class textbook, so that everyone can be familiar with the most recent and best developments and think of their own. There is marine biology classes, there's Intro to Environmental Sciences. You know, we are an institution that provides education, that provides opportunities, and it is our duty as students and as members of society to grab those opportunities and use them to better our society. So David, thank you again for coming and speaking. I'm sorry? I can't hear you. Donation, oh yeah. And then we have tons of events that we want to do, including one of my favorites that I've been trying to do for a long time that costs $3,000. I want to bring live leopards to College of Marin. Just put them out there. Right here, but no, seriously, there is an organization called Leopards, Etc., and they bring live wild cats that for education purposes, and it costs $3,000 to bring them. So if you are so inclined to have them as I am, please put something in the donation box and for other events that we want to plan in the future. And let us know too. We have a lot of connections.
My talk is free. I'm not getting paid.
Yes, that was awesome.
Thank you for your question.
No,